Hello everyone, let's talk about refactoring. Long methods refer to methods or functions that have grown too large over time. They often perform multiple tasks and they are considered an anti-pattern in software engineering. Some problems that long methods introduce are reduced readability, higher maintenance cost, and decreased reusability. Long methods are difficult to test, they are prone to bugs, and they represent a significant source of technical debt. ExtractMethod is one of the most common refactoring techniques used to address the issue of long methods. The idea is to take a code fragment from a long method and turn it into a new separate method, replacing that code fragment with a call to the newly extracted method. Modern IDEs such as JetBrains' IntelliJ IDEA have ExtractMethod capabilities. However, this is a manual process in which the developer has to manually select the code fragment to be extracted in a new method, and there are no automatic recommendations. Choosing which statements are profitable to extract has been the subject of many research tools that employ hard-coded rules to optimize software quality metrics. Despite steady improvements, these tools often fail to generate refactorings that align with developers' preferences and acceptance criteria. Our intuition is that given the fact that large language models or LLMs have been trained on a large code corpora, they are more likely to imitate human behavior. If we harness the familiarity of LLMs with the way developers form methods, we could suggest refactorings that developers are likely to accept. Our experiment on more than 2,800 real-life methods from open-source projects in which developers performed ExtractMethod refactoring reveals that LLMs are creative and prolific, generating more than 12,300 ExtractMethod suggestions. However, more than 45% of these suggestions are invalid, potentially resulting in non-compiling code. And almost 17% were not useful, for example one-liners or entire method body. Our tool EMAssist is implemented as an IntelliJ IDEA plugin. It leverages the creative capabilities of LLMs. Starting from candidates suggested by LLMs, EMAssist filters, further enhances, for example corrects code fragment scope, and then ranks the suggestions based on static analysis techniques from program slicing. To ensure that ExtractMethod is performed safely and correctly, EMAssist utilizes the full power of state-of-the-practice commercial IDE IntelliJ IDEA. Let's see EMAssist in action on Java code. EMAssist is implemented as an intention action. To trigger it, the cursor needs to be anywhere inside the method. Then we right-click and we select Show Context Actions. From the next menu we select ExtractMethod suggestions. What happens under the hood is that EMAssist selects the entire code of the method and prompts our LLM of choice, in this case GPT-3.5 Turbo, for ExtractMethod suggestions. A progress bar here at the bottom indicates this. EMAssist then further enhances, filters out invalid suggestions or those that could potentially result in non-compiling code, and ranks the rest of the suggestions, displaying the remaining top 3 to the user. For display, we use this pop-up window in which we show the length of the suggestion, the proposed method name, and the method signature. The developer then can inspect these suggestions and they select the one that is most suitable. Note that the corresponding code is highlighted with a purple hue in the main editor pane. To actually perform the code transformation, the developer clicks on the Extract button. The code fragment is replaced with a call to the new method, and down below we have the extracted method itself. EMAssist supports also Kotlin programming language. Let's take a look at an ExtractMethod example in Kotlin. Same as before, we right-click, we select ExtractMethod suggestions from the menu. The method body is selected and LLM is prompted to provide ExtractMethod suggestions. We can inspect the 3 candidates and let's say we pick the last one, the update static, and we hit the Extract button. To evaluate EMAssist, we perform an automatic evaluation on 2 corpora. In a syntactic corpus comprising 122 ExtractMethod refactorings artificially created by researchers and widely used by others for tool evaluation, EMAssist achieved a recall rate of 60.6%. This surpasses the previous leading recall rate of 52.2% achieved by comparable tools, whereas others have a much lower recall rate. On an extended corpus of 1600 ExtractMethod refactorings actually applied by open-source developers in modern codebases, EMAssist achieved a recall rate of 49%, compared to 23% for the previous best-in-class tools that rely solely on static analysis. This dramatic improvement shows that EMAssist better aligns with how developers refactor their code. On top of that, we conducted 2 human evaluations, the first one aiming to evaluate the quality of the suggestions. 16 experienced developers participated in this survey and 81% of them endorsed the EM-Assist's recommendation. The subsequent study aimed to evaluate the usability of the ExtractMethod workflow presented by EM-Assist. In this evaluation, we received feedback from 18 participants. A striking majority, nearing 95%, considered EM-Assist to be beneficial. Please reach out to us if you have any questions or feedback. Please visit the EM-Assist webpage to find out more about the workflow, requirements, configuration, installation, and many more. Thank you so much.